Hello guys, welcome back to another video in the Finance with Python series. This is Anirudh here, and today we are going to be going through some data visualization tools. The two main data visualization tools that we're going to see today are Matplotlib and Seaborn. So Matplotlib is a low-level graph plotting library in Python that serves as a visualization utility, and it is open source and you can use it freely. And Matplotlib is mostly written in Python with a few segments which is written in C. So Matplotlib provides extensive customization options that allows users to control every aspect, of the plot, including the axis, the color, style, and so on. But compared to Seaborn, Matplotlib requires more lines of code to produce, similar visualizations. So that is probably one disadvantage. And Seaborn is fairly, you know, recent, and it is built on top of Matplotlib. And you know, the aim is to simplify the creation of complex visualizations, and it also enhances the aesthetic appeal of the plots. Okay, so now let's get started. So Matplotlib has a pyplot submodule under which most of the utilities are present, and you can usually it is usually imported with a PLT. So you just import matplotlib.pyplot as PLT. And as to how you want to plot these graphs, you can give a bunch of X coordinates, you can give a bunch of Y coordinates and plot it. It is as simple as that. You can also give customizations over here. So this is the line style customization that you have here. Now, instead of dotted, let's say I want something else. Yeah, we can have a dashed line, let's say. So when you input that, you get a dash line over here. You can also, you can, instead of writing it in such a big, sort of manner, you can also simplify it saying ls equal to, um, yeah, this is, for the dotted, and for dash, we can give it as like this. So ls in short form for, line style. And here, this is very, very easy to understand. Like you can give the x-axis label, x-axis, and you can give the y-axis label as y-axis. I can change this up, say x coordinates, and let's give y coordinates. Change that, and it'll just show. So this is very basic. Let's go on. You also have a. You can also create this sort of bar graph between the x and y variables. So x equal to 1 is 10, right? As you can see here, and according to that, a bar graph is created. And you can also create a scatter plot. You can do all sorts of customizations with the Matplotlib library. Also, something that I didn't mention is, okay, you can also give it like this. So instead of calling it as plt.scatter, you can also give another argument saying, yeah. So this is the same as a scatter plot. As you can see here, these two are the same. Yeah. So this references a scatter plot, the small o. So it just means that all the data points are going to be represented with a circle format, small circle o. Yes. Now let's look at markers, right? So let's go back to the initial dotted lines, and let's also give a marker. So what is a marker? Marker is like, you highlight a particular point using a certain type of symbol. So let's say star is the symbol. So on a dotted line, you want to represent, these points. You want to highlight these points. So you use a marker for it. See? So you mark this, 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 this. Yeah. So that's the main job of a marker. It just draws your attention towards specific points. You have a lot other markers like, let me just show you. So let's see all the available markers over here. Yeah, you have zero, which is a circle. You have descriptions for everything. You can do a point, comma, small x, big X, plus. Let's try this one, the last one, underscore. So it's called as a hedge line. You can see that the underscore is found here. So these are called as markers. We can do a bit more of experimentation with this. So now let's try, this sort of small um let's try customization now. So let's say you want the marker to be a circle. So you give O, right? So essentially this is a marker. And you also want, let's say, a dash line. You can give a dash. You want the color to be green, so let's give green. Let's see what happens here. Yeah. So you can see you can give these three in this sort of short form, and this makes your life very easy. You can give a dash line also. You can change up the marker, you know. Okay, comma. It doesn't reflect, obviously. Let's give X. Yeah, so you can see X over here. Yeah. So these are some, small customizations and certain interesting things that you can play around with. Okay, so let's delete this. We don't need this. Yeah. Now, now what we're going to do is we're going to look at an actual stock data set. Let's say Google. So, we're just importing Y Finance, Matplotlib, and Seaborn. These two are the visualization libraries, and this is just, another library to get sort of real-time stock data. Yeah. So you download the data, store it in the data underscore Google, and now you are creating a figure. So what the dot figure does essentially is you just get the sort of palette of 10 cross 6. So the width is 10 and the height is 6. So that is what 10 cross 6 means. So let me just, separately run that so that you can understand what sort of outputs. Yeah. See, so you can see that you get a figure of this particular size, right? Yeah. So just, need this now. Huh. And you are what is this plot showing? This plot is showing, the closing price according to the dates. So x-axis is the date and y-axis is the closing price. I've given the data underscore google dot index over here, the dot index over here, because let's just look at how the data set is. Yeah, so these are the indices, the dates are the indices. So that's why we have given a dot index over here, and you're referencing it with, the closing price, and you're giving the x and y axis labels and the title. Yeah, so you get this sort of plot when you run it. Just run it again if you want. Yeah. Now, what sort of customizations can we do in this? Let's say I want a dotted line, you know. Yeah, dotted line. Marker, sure. It's going to be very cluttery, because I've added the marker. It's going to be very cluttered, but yeah, I think we can stick with this. This looks more appealing to the eye. Yeah. Now in this, we're just, plotting the volume of the stock along with the date, right? Just similar to the closing price, you're just plotting the stock. Sorry, you're plotting the volume of the stock day on day, you know. We don't need a marker over here. So now I had implemented, the stock price according to the date on Matplotlib. So now let's try it with Seaborn. Oops. Let's try it with Seaborn. Run this. I've just done the same with Seaborn. So you have a dot line plot function in Seaborn. You can specify the X and Y axis. Very simple. X axis is the index, which is the date, and Y axis is the closing price. Now we have tried to, flatten these values because as you can see in our data set, the closing price is not exactly one dimensional, right? So dots, we can just look that up pretty quick. Yeah, it's not one dimensional. So you want to extract this part alone. So you just flatten it. I flatten it over here and then I use it. So let me just show you what happens if you don't flatten it. It'll just show you an error saying, you need a one dimensional, but got an n dimensional array instead. So it's just, much easier to just flatten it. So these are some tricks that you can do. Yeah. Here we have made a histogram plot. Okay. Now we are looking at, the distribution of Google's daily return. So now what we have done here is how do you calculate the daily, return? So previous day closing price and today's closing price. You take this sort of delta of it and do a percentage over it. You get, the percentage of daily return. And that is essentially what you've done here. You've just made sure that, there is no bad value, as in there is not an NAN value over here. So we've dropped all those uh, NANs and we have arranged this into, bins of, 30 intervals. That is what bins equal to 30 means. And KD is called as the kernel density estimate. So this is the sort of curve that, it sort of provides, a smooth representation of the distribution. And that is what the kernel density estimate does. KD is like pretty, useful to visualize. Now, we can also visualize, the volume and frequency distribution. Yeah, so look at that. This is just another Seaborn visualization. We use another histogram plot, and here instead of here, you're taken like the closing price to calculate the daily return, right? Here you're just using the volume versus frequency. So stock volume distribution. This is just a volume distribution plot using Seaborn. So here we had seen that you had, plotted it over here. This did not, look appealing to the eye. Like you can't visualize anything from this. But when you look at this plot, this seems, a bit more appealing to the eye. It's like you can understand something from it. See, you can see here that, the mode of, the stock traded is this one, this big line over here, this big bar over here. That bar is like uh, the most frequent volume traded, which is around, I would say, 0.25, somewhere around that range. Again, this is all, brought down to, minute value. It has been scaled down. So just ensure that, the scaling factor is right. Now we can also have a correlation matrix, so SNS also, Seaborn as an SNS also gives you an option to have a heat map. So what is a heat map? So heat map is like a big matrix, and every it is color coded based on the corresponding correlation with different variables that are involved. So open, high, low, close, volume. These are the five variables. You take a correlation matrix, store it, and you take the heat map of this matrix, right? So you don't have to, get scared of what all each of these are. These are very easy. FMT means is just that, you're rounding off to two decimal places. Cool warm means that, blue is like the lower end of the spectrum and red is the highest end of the spectrum. Annotations is true means you just get all of these, annotations. So open Goog, high Goog, those are all called annotations. And you just give a title and show the plot. So from here you can see that let's try to understand something from here. You can see that the amount of volume traded directly affects the opening, high, low, and the close price, right? So that's what you can see from here. And most of them have very similar correlations. Yes. Now let's look at the next plot. Next plot is going to be another percentage change. So what we are trying to do is this shows you the volatility of the stock over time. So we have calculated the returns over here. So what are we essentially doing here? So we have the close price. We are taking the percentage. Sorry. So the percentage of close price over a window of 21 days, we are taking that and computing the standard deviation. That is the simplification of these two statements, right? And now we have calculated these two parameters and then we just, simply again plot it. The plotting part is very easy and this is the more important part to say. So you should know what to plot. Plotting is not the hardest part. Knowing what to plot and how to gain, you know, how to gain insights from it is more important because you can also plot stuff like this. You can't make out anything from this. It's like so cluttered. But if you want a much better plot, you should look at, a 21-day rolling window. Instead, you should have a plot like this where you can actually visualize something. You can actually see that the most frequent traded volume is this big bar over here. So things like this you just have to keep in mind. Now, let's also look at how to get the traditional candlestick pattern. You know that's what is more useful, right? So we have a library called Plotly. Okay, so this is an open source library, and this gives you the candlestick option. Uh, Matplotlib and Seaborn do not have this option, so we can use the candlestick option to sort of you know visualize the opening and closing price as it is seen in the trading platform. So let's go to a popular trading platform like Trading View. So let's just click ICICI. Yeah. So you can see the candlestick pattern here, right? This is what the traders want to look at. This is what is interesting for them. Yeah. So that's what we are trying to do here. And when you go over this, you can see the opening, closing factors, up here, this one. You can see that opening, high, low, closing. You can see all of those for each and every candlestick. And that's what Plotly allows you to do over here. So you can just click over here, you get the date, opening, high, low, close. So this, I would say, is a very useful tool in reference to how you perceive stocks. Very useful. So anyone wants to build a dashboard and they sort of want to show a stock, they can use the Plotly library and simply do it very easily. Now here we have done a bit more of manipulation on the variables. So here we have tried to calculate the moving averages. calculated the 50-day moving average and the 200-day moving average. So what is a simple moving average? So here, here you just sort of take the closing prices over a 50-day window, right? The window is 50 days and you take the mean and plot it. That's what you've done here. It gives you this sort of graph, which means that it gives you the average of the 50 days before the day. So this is the average of the last 50 days starting from here. And this point is the average of the last 50 days starting from here, right? And similarly, you have a 200-day moving average. So we have sort of wanted to plot this. Similarly, you create a figure of a certain figure size, plot the data. What do you want to plot? You want to compare the SMA 50, SMA 200, and the closing price, right? So you plot them with different colors, give them, the appropriate labels. So you have the labels over here and with colors blue, red, and green, right? So you're labeling them, giving the title, which is over here, the x-axis, the y-axis, you give the grids and you show the plot. So this is a brief tutorial on powerful visualization libraries, how they can be used effectively to give you maximum visualization and insights on your data. Also remember, visualization is easy if you know what to visualize. So I would like to end the video on that note. Thank you. Thanks for watching.